Okay, so hi everyone, we'll get started. So thanks for coming. My name is Allison. That's not clear yet from class. So I'm a grad student right now, so I'm just an IA. I help Dr. Altimos, but I already have a degree and I'm working on another one. But I do my office hours slightly different, or I've done them in the past slightly different, where I come in and you can ask me questions, or I kind of and I'll tailor everything to that. But I like to work through practice problems during my hour and a half that we have together. That way, I think it just gives you a little bit more practice with chem, and I know I learned chem through practice problems, so I just want to give that back to you as well. But I'm here for any sort of questions that you may have, so I always ask if there's anything you want to start with, and then I can give you some practice problems if there's not, but I'll always tailor something towards what you want to see today. So what do we want to see today?
You covered in class and I didn't really understand it.
Absolutely. So a lot of what we covered in class today is the difference between ionic and covalent bonding. Okay, so there's two different types of bonding that we're going to see, which means that there's two different types of compounds that we're going to see throughout chemistry. So can someone tell me what an ionic bond is, or what we usually see that between?
Metals.
So usually with ionic bonding, we have a metal and a non-metal. What is the other way that we can see an ionic bond that she talked about?
You mentioned polyatomic ion.
Yep. So we could have some sort of polyatomic that we're going to see in our compound as well. So an example of a metal and a non-metal. Does anyone have an example of a metal and non-metal?
Carbon and oxygen. No, wait, non-metal and non-metal. I'm thinking two non-metals.
Yep. That'd be good for covalent. But what's about
Iron and oxygen?
Iron and oxygen could be one of them. Talk about that one today. What's a common one that we usually see? You probably use it every day. Or you can have something. We have sodium chloride, right? Where you have a metal of sodium ion and then chlorine, and then it's chloride ion. Those two separately, as sodium and as chlorine, are actually very reactive. But when they come together, they make table salt. Because it's not very reactive. But the key here is that if we were to break sodium and chlorine into its two ions, we have a Na plus and a Cl minus. So where this ionic bonding is coming from is that we have this charge here on both of our ions that's causing that interaction between the two of them. Right? Think of this as like a magnet. You have the positive end of a magnet and the negative end of a magnet. They're going to come together and form the bond. Same thing happens with a polyatomic ion. Does anyone know a polyatomic ion?
I know ammonia was one. Or isn't water one as well?
Water's just a regular covalent one.
Okay.
So
the poly is for itself, right?
Yep. Yeah. So multiple atoms usually. So ammonium is a polyatomic ion. This is one of the positive ones that you'll typically see for the polyatomic ion. But there's also nitrate people usually see. I think it's this. And then sulfate is another one that people usually see.
No.
Right, but all of that chart that you will that you give to you on in your slides, that will be given to you at some point. So you don't need to know them, right? You don't need to know that this is ammonium. You just need to know that NH4 plus is a polyatomic ion, or NO3 minus is a polyatomic ion. This might be a minus, but that doesn't matter now. Okay. So when we look at polyatomic ions, again, we have this charge component associated with your ion, and that's what makes it an ionic compound. Questions there? Yeah.
So sorry, because I kind of just don't hear something tripping a little bit. So polyatomic ion, poly means more than one.
Yep. And
then it makes it an ion because it's a metal and a non-metal.
Yep.
And then the charge does what? I'm sorry.
So the ion here is that charge component. So if we just had sodium, we just had sodium metal, this is not an ion. when it has that plus, now it becomes sodium ion.
Okay. And then the Fe2O3,
Mhm.
what would that be?
Yep, so Fe2O3, we kind of talked about this in class today. So what did we say iron's charge had to be here?
Oh, 3
Mhm.
positive 3,
Yep, so we would have iron 3 plus, and what does oxygen have to be?
-2.
Yep, and then we would have oxygen 2 minus. And we would have 2 iron atoms, and we would have 3 oxygen atoms in order to balance this out so that the 3 plus and the 2 minus would each be 6. Okay,
And the 3 plus, like, we get it.
so we know that iron on the periodic table, do you know where that is in the periodic table?
No.
So it's in your transition metal section. So on the periodic table, so right this here.
One of them will always be given to us to find the other one though, right?
Yes, yep,
You
you'll always,
technically find both of them on the
Yes.
periodic table.
yep. So these are gonna be your metals. These are your non-metals-ish.
And then it's like excellent.
Yep, and all of this is your condition. So these transition metals, this is where iron is located. And these transition metals all can have various states of this positive charge. Right, they're always going to be a metal, right? It's a transition metal, so it'll always be positive, but it can be varying, right? We saw the vanadium V can have 4 different positive charges associated with it. Iron typically has 2, it has +2 or +3. Okay, there are some elements within the transition metal section that do only have 1. One of them being gold, right? Gold can only have a +1, silver can only have a +1. But most of the time you'll be able to figure that out from the compound that it's in. Okay, right, so if we were to look at something like AgO2, Ag2O, we know that oxygen has what sort of charge?
-2,
-2. So what does Ag have to
positive
have
1.
to be? +1 overall of +2, because we have 2 of them here, plus +1 times 2, and that +2 now balances out that -2. Can you see how we found that one? Any other questions so far?
What will be the difference between the polyatomic ion
Mhm.
and then the one above it where it like NaCl, for example?
Yep. So when we look at like iron oxide or sodium chloride, those are specifically a metal and a non-metal, right? We have our metal component here, and we have our non-metal component here. Okay, so those are always metal and non-metal. When we look at polyatomic ions, in the case of NH4 plus, this one can make a bond or make a compound, whereas NH4 plus, and then maybe chloride, right? So now we have a polyatomic ion, and then what is this called? Is that like as in a metal or non-metal?
Oh, that's non-metal.
That would be a non-metal, right? So we have polyatomic ion and non-metal. But if we had the sulfate ion, this could be magnesium sulfate. Now we have, what is magnesium? A metal, so this would be your metal component, and now you have a polyatomic ion. So it's not always going to be a metal and a non-metal, but it will have either one of those depending on the polyatomic ion used. Do we see how that is different from the metal and non-metal directly? Right? Your metal and non-metal is going to be this section and this section, where your polyatomic ion is going to be a blend of kind of the whole periodic table. Any other questions on ion? Okay, and then we didn't talk about naming in class, but this is something that you should be able to recognize in terms of naming. And I have like a worksheet that I'll post along at the end of this review session, or we can go over a little bit that practices some names. But when you're doing your metal and non-metal, if it is strictly like sodium chloride, you don't need to state how many or what, how much of each that you have. But with your transition metal section, if you have an iron, that's where the Roman numerals come into place. So in this case, since iron is 3+, this would be iron Roman numeral 3, and then oxide. And that tells you what charge iron needs to have. When you're naming stuff with polyatomic ions, you don't need to use your Roman numerals because your polyatomic ion will always have a given charge. And so you know how much of the other one you need because you know how many polyatomic ions you have. Questions? Okay, so then on the other side, we have covalent bondings. So what do we say covalent bonding was? Yep, it's between non-metal and non-metal. Yep, so that would be perfect. That would be like H2O. What else do we have? Yep, NO2. Anything else?
I mean, you could just mix anything.
Yeah, pretty much, right? You can have carbon monoxide, you can have carbon dioxide. Okay, in this case, all of your non-metals and non-metals are going to come from this side of the periodic table, right? These are all your covalents.
Do you happen to know if it's important to know, like, for example, they give you an I don't know, for example, NH4,
Mhm.
and then they ask you, like, they don't just ask you if it's an ionic or covalent, but it also asks you if it's like metal plus non-metal or polyatomic plus metal or something like that.
So if we're just looking at NH4,
Mhm.
where is nitrogen on the periodic table?
On the right side.
It's on the right side, right? It's about here. Okay, where is hydrogen?
On the left.
Yep, it's on the left all the way up here, but it's technically still a non-metal. So in this case, what is bonding NH4? Ionic or covalent interactions?
Oh, covalent.
This would be covalent bonding, making a polyatomic ion.
Oh.
Okay, if we're looking at nitrate, nitrogen and oxygen are right next to each other on the periodic table. This is covalent bonding creating a polyatomic ion. Sulfur and oxygen are right above each other. So this is another covalent bonding creating a polyatomic ion.
But it would be considered a covalent compound, right?
You would consider it a polyatomic ion.
Right.
Yeah. Yep.
So NO2 would be also a polyatomic ion instead of now NO3, NO2.
Yes, technically NO2 is a different type of polyatomic ion. And that's because it has a charge associated with it.
So what creates the differentiation?
So your carbon monoxide, carbon dioxide, H2O, what is different about that compared to your NO2 minus?
It's charged.
One has a charge. So when you start adding charges into your covalent compound, that's when it becomes a polyatomic ion.
The other ones are balanced.
Mhm.
Okay.
Can you distinguish the charges from?
You would be given the atom or the compound along with the name. So you would have the chart to just look at and say, okay, I have NO2 minus, so that must be a on the chart. Now you know what that is.
So anytime you see a charge, it's polyatomic, right?
Anytime you see a charge, for the most part, yes. As long as it's two non-metals with the charge, it'll be a polyatomic ion.
Okay.
Yep. Because you can have different things every once in a while, but so I don't want to say always. I'm like using a couple exceptions. So for the most part, if you see a metal or a non-metal and a non-metal with a charge, that'll be a polyatomic ion. In those right naming, you'll just have a chart for those. But in terms of your naming of regular covalent compounds, right? We said this was carbon monoxide. If there's only one at the beginning, you don't need any of its prefixes, but when you have one oxygen or two oxygens, right, then you're gonna say monoxide or dioxide, right? This is carbon monoxide, because only one oxygen, this is carbon dioxide, because there's two oxygens. This H2O would actually be dihydrogen monoxide, right? So you have two different prefixes that you're using in order to name water.
Mm.
I have a couple of examples of that later too for more practice. Any other questions? Does that help clear up a little bit of what we did in class today? Yeah, do you want to do a couple practice things?
Sure.
Yeah.
Would the periodic table be given in the exam?
Yep, it'll always be a attached to your exam sheet. Yep. And then she usually displays it on a
Oh, that
screen
comes-
as well.
yeah.
Yep. Okay, so for each of these three compounds, we're going to answer these three questions. We want to identify the compound as ionic or covalent, and then if it's polyatomic, we're also going to make a notation of that. We want to write the name of the compound and then identify the charge of each component. So let's try A together, and then maybe you can try B and C on your own. So for compound A, we have P2O3. What is this going to be in terms of the compound as ionic, covalent, or polyatomic? And why is it covalent? Yep, we have two nonmetals. We have phosphorus. And we have oxygen. That's two nonmetals in our compound.
But if you would have given us a charge, then it would have been polynomial.
Yep, perfect. Okay, so that's identifying it first. Now we want to write the name of the compound. So how are we going to write the name of this? What do we need to use?
There's a rule, like if it's something, then you use the notations.
Yep, so if you So I guess we could either just say it directly as phosphorus oxygen. We could
Phosphorus
use,
Dioxide.
Diphosphorus.
so because we have covalent interactions, we need to use our prefixes. We have two phosphoruses. That's the plural. So we have diphosphorus.
On ionic, you don't use the prefixes. That's what I was wondering.
Yep,
Or polyatomic, right?
right. Yep. And then how many oxygens do we have? Tri, right? So we have tri. Dioxide, right? We're gonna change oxygen to oxide. Questions on how we named that one? Right, 2 goes to di, 3 goes to tri. 1 is mono, 4 is tetra, 5 is penta. Well, I think that's probably the most you're gonna need. Okay, and the last one is identify the charge of each component. So look at, like, if we're gonna say what's the charge, we broke this up into phosphorus and into oxygen. What's going to put the charge on both of these?
Wouldn't it be 3 and 2 minus? Because we find charged oxygen from the table.
Yep,
And then-
so actually phosphorus and oxygen will both have standard charges for this one. So whenever you see phosphorus and oxygen together, they in terms of just like this here, right, you need to have this as a -3, this as a -2.
But if you were given a question like that, where would we start by finding on the periodic table?
I would always start with oxygen.
Okay.
If there's an oxygen given in your compound, I would start there, because that one will always be -2. There's one exception to that, but that comes later on, so you don't need to know that right now. Okay, but -2 will always be oxygen here. That's a good starting point, and then you can check your work. So if you know that phosphorus is going to be -3, you can check to make sure that the math that you do comes out to -3. Questions on A? If you want to try B and C on your own, then we'll reconvene in a couple minutes.
Wait, real quick, so they're both negatives of that charges?
Yes, yep, because it is a metal and a non-metal. So if we were like for the non-metal and non-metal, it's a little weird to give them both charges of negative, but just for the covalent stuff, just kind of go with it for right now.
The covalent has 2 negatives.
Yeah, and that's where like a lot of the polyatomic ion stuff comes into play and all that fun stuff. But for right now, I just want you to say that like this would be a -3, this would be a -2.
Okay, but then how would it add up to 0?
Yeah, that's what I was like.
It's
Is that only for ionic?
it's mostly for ionic compounds. But I just want you to practice with what it would be to split them up.
So covalent, they would both be negative.
Yes, yep.
Okay.
So when you see like B is going to be one where they will add up to 0. So that's like a better example of that one.
But isn't that covalent? Oh, wait, no, I'm looking actually. No, never mind. Never mind. Yeah, I can see that.
All right, did we get an answer for B? For number one, identify the. Yep, so this would be ionic.
Stuck on the name, though. We got sodium, and that's what I was wondering about.
Okay, so we have ionic. Is there anything else with this one?
Oh, it is.
So this one is also polyatomic.
But we would have known that because it would have given us the chart.
It would have given, yeah, and usually probably at the top of all of your questions, you would be given the chart for it, but on your exam, it'll probably be your periodic table on one sheet, on one face of the paper, and then the polyatomic chart on the other. So it wouldn't be like, oh, here's a chart that goes along with this question. You would kind of have to say, okay, I think I need to use my chart for this one. Okay, so this one is ionic and polyatomic. Would anyone know what the name would be?
I put sodium and then the 2 in Roman numerals in parentheses and then sulfate.
Okay, so you're very, very close. Because we have sodium, which is just a regular metal, it's not a transition metal. You don't need those Roman numerals, so it's just going to be the sodium sulfate.
Would sulfate be given, or will we have to?
Yep, that would be in the chart.
Okay.
Yep, and the only reason you don't need those Roman numerals is because sulfate will always have a -2 charge. Just like how oxygen always has a -2 charge. We know that like sulfate, this SO4 right here would always be -2. We know that sodium always has to be +1. So we would always need 2 sodiums to match that 2- of our sulfate. Right, so very similar to how we would name sodium chloride in this situation. Questions on how we named the polyatomic?
A little bit. So how do you know that it's ionic and polyatomic?
Yep, so whenever, we both went over it briefly before you got here,
Yes.
but no, it's no problem. But this is gonna be your metal. So that kind of already puts you in the fact that it's gonna be ionic. And then SO4 is just something that you're gonna recognize as a polyatomic ion. You don't need to know necessarily what the name is, you just need to know that, okay, SO4, that as a clump is gonna be a polyatomic ion.
Okay, thank you.
And so this here, this being a polyatomic ion, is what kind of directs you towards both of those. If you wanted to split them up into the positive and negative charges, that's what both of them will be. Okay, so if we're gonna write the charge, we're gonna take Na2SO4, and we're gonna split this into Na and SO4.
So you wouldn't separate like S and then O?
Nope.
Okay.
So whenever you see a polyatomic ion, that stays as its whole clump. There's an acetate ion, which has 3 compounds in it, or 3 atoms in it. Carbon, hydrogen, oxygen, that's all gonna stay as the acetate ion, it's all gonna stay as that CHO, whatever that is. So whenever you see a polyatomic ion, it stays as that unit.
Since SO4 comes with the 2- with the other one before, so you could.
Is there any charge associated with this compound?
Sulfate?
Yes,
With
2-.
overall,
Oh, no, there's no charge.
no
Yeah,
charge.
it'd be
So
zero.
it's gonna be, okay, so it's gonna be +1
Would
with
it?
the sodium.
I thought it would be 4+ because it balances to 8.
Yeah, that's what I put.
So,
Because SO4 is like when you multiply it by the actual number of atoms, I mean molecules. or
okay,
whatever.
good point. So whenever we're looking at SO4, I need more room. So as a polyatomic ion, you think of this as SO4 2-. So this whole thing has a 2- charge, not just the oxygen of 4, but this whole unit is 2-. So you don't need to multiply anything by 4. Good thoughts.
Just wanna know it's
You just need to
whole.
know that this in your compound is the 2 minus.
So then would sodium be?
What goes to sodium?
+1.
Yep, so then the sodium would be +1
Oh, because it's two of them.
because
Got
there's
it.
2 of the sodiums. Yep. Right, and so this is something where she showed you aluminum and oxide and oxygen in class or in your notes. But if you're looking at Na2SO4, she said, right, she drew the arrows. So this 2 comes up here, this 1 comes up here. So now this breaks into Na+1 and SO4 2 minus. That's where that comes into play.
So like NH4, if that had a, just off random, that had a 3+ charge, it would just be as a 1.
Yep, so and that, right, we said NH4 ammonium is a polyatomic ion. That's because this whole thing has a +1. Yep. Think of it as like just a sandwich, it has to stay together. They're twins that can't be separated. So you have 2 sodium ions that both have a +1 charge that balances out the 2 minus charges of that 1 sulfate atom you have. That help a little bit with the polyatomics. Yeah. Okay.
The only thing that like confuses me is that the covalent has a 3 minus, so it's like the only part.
Yeah, don't worry too much about this. Don't put your, we'll just pretend it didn't happen. Don't worry about that too much. Because most of the time it's gonna be with an ionic compound that you're doing the charges. And so it'll always be a plus and a minus component of that one.
Okay.
Yep.
So it'll always just balance out to 0,
Yep.
basically. Okay.
Or it will bounce up to 0 or whatever charge is on that compound.
Okay.
So if you had something, we'll just call it X, Z. And this was 2 minus. And then this metal here and this non-metal here have to add up to -2.
Okay.
Okay. Right, so for some whatever reason, NaCl had a minus charge, then whatever chlorine was and whatever sodium was had to equal up to minus. Any questions on that? Okay, so then C was CCl4. Is that going to be ionic or covalent? This is covalent. Or even name CCl4.
I thought carbon tetrachloride.
Beautiful. Yep.
A little tricky with the charges. We don't have like exact.
So what's going to be the charge of chlorine all the time?
Are we supposed
Is
to
it just
memorize
four?
that?
Yeah.
Or?
Yep, so we can look at that,
Oh, yes, 2 minus.
not 2 minus, plus -1. Chlorine's always going to be -1.
So do we just do that, cause like, it's in like the group that's right before the last one?
Mhm.
So that's how we like find the charge?
Yep, well, we can do that. I'll show you the periodic table. We can go over that right after and all that fun stuff. Right, so chlorine is always gonna be -1. So how many overall negative charges do we have?
4.
We have 4, right? So this has 4 of them.
So then we need 4 positive.
So we need 4 positive charges. Carbon is a non-metal, but if you have to take orgo, you learn all about the beauties of carbon. And carbon can either be a minus or a plus. So in this case, this one is carbon 4+ and fluorine minus.
So yeah, could you explain the difference between that one and the other?
Yeah, so basically the difference here is carbon. Carbon is a fun little thing, fun little atom that can hold either +4 or -4. But phosphorus is one more family over, one more row over, and so that one sticks as a non-metal.
So if we were being quizzed over it and it was a covalent compound,
Mhm.
it would have negative charges unless it was carbon.
Yes, yep. Carbon, you can can either be +4 or -4. I think that might be on your slide says that too. You'll kind of see a dash where it says +4 on one side and
So you
-4
try to
on the
add up
other.
to like 0, but you still keep it
Yes.
as a negative.
Yep.
Okay.
Chapter 2? I did chapter,
Any questions on our examples here?
oh, I did chapter 2.1.
Okay, so let's look at the periodic table.
Did you do chapter 2? Let's do it.
We'll draw. We'll make just one again.
Oh, it's not. I don't know.
Okay, so this is.
Mhm.
So just looking at the first 3 periods, our first one is going to be hydrogen and then helium. Lithium is going to be our first metal on our periodic table. Does anyone know what these first period is, or first family or first row is called?
Alcohol.
These are going to be your alkali metals.
That's something we have to know.
Just recognize, I think. But just know that all of your alkali metals will always have a +1 charge. What do we call a positive ion?
Cation.
Okay.
The only reason I know it's because cats have paws, like positive.
Okay, I like it. I think.
I swear.
A little bit cheesy.
It worked.
I mean,
Don't worry.
it works.
Hey, I got
It
plenty
works.
that's coming up for the rest of the semester of things that help me remember stuff even to this day. So I like it. So your cation is going to be positive, and then this second group here, all of these, what is that? What do we think that's going to make?
+2.
+2. Yep. Okay, so anything in this row is going to be +1, anything in this row is going to be +2. So that's why sodium always makes a +1 charge, and that's why magnesium always makes a +2 charge. You'll learn more about why it always makes +1, why it always makes +2 a little bit later in the semester. But for right now, you just need to know that if it's in this row, it's +1. If it's in this row, it's +2.
Does the periodic table in the exam have that, like +1, +2?
Nope.
Oh,
It's not too bad to read.
It's not too bad. The more you work with them too, the more you understand how useful the periodic table is. There's a lot of stuff you can get from the periodic table just by looking at it. Okay, so the next part of our periodic table is that start of our non-metal section. Does anyone know what we call neon or even helium for that example? What are they noble? These are your noble gases.
oh.
Right? Our noble gases, are they going to be reactive or non-reactive?
No,
They're non-reactive, right? They
That's why
don't
they're
like to
noble,
do.
because they don't mess with the commoners. See, we also use some things to remember
That's
things,
fine.
okay?
I like
Listen.
that.
So you gotta do what you gotta do to help us.
Okay, so these are your noble gases, they're non-reactive. All of our elements on the periodic table want to look like a noble gas. And that's why they're gonna end up making those +1s, +2s, +3s, or even like your -1, -2 ions, because then they end up disguising themselves as noble gas.
Because they are the most stable.
Yep, they are very stable, so everyone else wants to be stable like them. Wouldn't know what that means. But for fluorine is one away from a noble gas.
first major.
So if fluorine is one away from a noble gas, but it's a non-metal and not a metal, do you think that's gonna make a positive or negative ion? It'll make a negative ion. So does that mean it's gaining or losing an electron?
Losing.
It's gonna be gaining an electron,
Oh,
right? If it has an
so-
overall negative charge,
Oh,
it's gonna be gaining an electron.
obviously.
How many electrons do we need to gain to get to a noble gas?
One.
Just one. So
Starts there.
everything in this row is going to be a -1, what we call a negative.
So normal gases are 0.
Noble gas is 0.
Yeah, because they have a full valence electrons, they have all 8.
Yep.
Yeah.
Oh.
So, and what do we call a -1 ion? Or like a negative ion?
And
Yep.
And that's why, since that one's like the 7A section, since it has 7, it's missing 1 to be a complete 8.
Yep, so you need 8. Yep. These will always be a -1 anion, so that's why
I learned that like 5 minutes ago.
fluorine,
It's wrote like 7A. So it wants a total of 8. So since it's missing 1, it's a -1. And then the next one's like 2 because it wants to go to 8.
Oh.
Mhm.
I learned that like 10 minutes ago, like in the last like review thing. So
Yep.
Smart.
So I do think on the periodic table that you get in for your exams, it says like 1, 2, and then
3.
I think it's,
4.
yeah, because it should be 13, 14, 15, 16, 17, and 18. And then in here is your 3 through 12. Right, so then they say this is 3A, 4A, because it's not 3, 4, because eventually these 10 come into play. But you can just think of it as 3, 4, 5, 6, right, on that side. So that also helps you there. Right, but we're 1 away from 8, so this is why this is always going to be a -1. That's why chlorine is a -1. That's why you only need 1 sodium ion and 1 chlorine ion to make salt, because you have a +1 and a -1 coming together to make a 0 charged element or 0 charged compound. Questions there? How many away from neon is oxygen?
2.
2. What charge does oxygen usually make?
-2.
-2. Everything in this row here is going to be a -2 anion. That's why nitrogen score is going to be -3, and then carbon, right, is 1 is right 1, 2, 3, 4 away, or 1, 2, 3, 4 away. So that's why I can do +4 or -4.
But that only works with carbon, so like the one right underneath it wouldn't be like that.
Yeah.
I don't know what color it is. Is it this one? See?
This is silicon.
Oh,
Yeah, it's- see.
Silicon has similar properties to carbon, but carbon is the most +4 -4 situation.
The other one would just be -4.
You would assume that one to be -4.
Okay.
but they change depending on the charge that you're given to solve the problem.
yeah.
We always
Or-
have to be given one in order.
You always have to be given one, right? So if you have something where it's like, if we want to say how many lithium atoms do we need in lithium nitride, what charge is nitrogen gonna have?
Say that again.
What charge is nitrogen gonna have?
If we're looking at the table,
Yes, right, nitrogen will always have -3, right? If we had. No, you can write this, right? Anyway.
I
Right,
see.
we're trying to figure out how many lithiums we need in order to make this neutral charge. What is nitrogen's charge always going to be? -3. So how many lithiums do we need in order to balance out the nitrogen? We need 3 of them, right? So we need Li3N. Because what charge does lithium always make? +1. So we need 3 of those +1 charges to balance out that -3 charge. What's going to be for your lithium for the oxygen compound?
+2.
We need 2 of them
balance up the oxygen.
to balance out the 2 minus from oxygen, and lithium is always going to use a +1. So you need 2 of those +1s in order to balance out the 1 minus 2.
It clicked with me earlier too.
And then if you don't like the cation, cats have pause and positive. How I remember is that an anion, this is where you have the N, and the N is negative.
There's T and cat.
Yeah, yeah, and then I think the cat, and I make a positive sign. Cats as pause, it's my, again, 7th year in Gen Chem, I haven't heard that one before, so that's pretty good. Okay, does that help a little bit on what always gets a charge and what doesn't get a charge yet?
Is boron +3?
Boron would be positive, right? Yeah.
Can I just take a picture?
Why would boron be positive here?
Because you are 3 away from 1, 2 helium this way.
So wouldn't it be like -5?
No. Nope, so usually at carbon,
That's
this is where it's like metal, non-metal.
Got it.
Yep, and that's the line also, there's like this line across the periodic table too, that's where you're, that's non-metals and then metals.
What about everything like the transition?
Transition metals, this is, right, these are your transition metals.
And the ones at the bottom too, right?
Yep, and then your little extra guy down here. These will always be positive, it just depends what positive.
Oh,
Okay, it depends on, right, that's where the iron 2 or the iron 3 comes into play, or vanadium 5 comes into play. But they will always form cations, they will not make anions. Right, these are all metals, your first and second rows are metals, they make positive. Transition metals are still a metal, so they will also be positive ions.
So metals are always positive because they're conductors.
Yes.
Okay.
Right, if it was making negative, then there would be nowhere for the negative charge to flow. Questions on the periodic table? You're gonna come to love the periodic table. It tells you so much that you don't know yet. It's right at your fingertips. That help so far? Help with stuff that we did in class today?
Yes.
Yes.
Exactly.
Okay. Beautiful.
Shouldn't,
that's what.
shouldn't this be covered in class?
I think
I thought the naming was covered.
The sheeper, and
It's
then,
probably
yeah,
just like
like-
time wise.
I think, yeah, it's pretty much just time.
You have to come with stuff like this to figure it all out.
Yeah.
And if everyone pulls up, it's just.
Yeah, I feel like, right, maybe sometimes in high school, they might be able to cover this a little bit more. Cause you just have, right, you go to class every day, but we don't have class every day here. So yeah, you have to do a little bit extra deep diving or extra help and stuff, but that's what I'm here for, and part of life. Trust me, I can't tell you how much time I spent on extra stuff in class, so that's the whole point of like spending time outside of class also learning. Okay, so we have about like 10 minutes. Are there any other questions we have? Yeah.
Can you go over like the structures that she have within class where this? Let me pull up the-
Yep.
I think that's like a deeper dive later this semester, right?
Structures, yeah, yep.
It's just on the whole book
Yeah.
and I don't know how to do it.
Wait till you hear all of those things.
Love
that
your
happen for stuff.
screensaver. Love graphic novels.
Thank you.
You could have built those now.
Yeah, I pre-ordered it.
I did it, but I will do it.
It's a bad.
You'll grab your balls
decision,
in?
but I-
Yeah. Do you remember who Bill was, the triangle guy?
Yeah.
Apparently he wrote a book, so it's like.
No
releasing
way.
Sometime this year.
I used to watch it.
I love graphic balls.
I liked it, but then they got like the teenagers.
How did you go to it? Like you said, that you with stuff.
Oh, you don't like it.
I just thought it happened. There's like
Yeah,
a question on the homework.
Yeah,
Oh, what's the question?
it's just like asking you to like count how many there are, and then that's really all it has you do is count how many of the actual.
Like how many different structures there are?
Okay, so there's like four.
Sulfurs there is.
Yeah, so there's like four hydrogens that we consider four molecules of hydrogen. What's that?
Yeah, yes.
Yeah,
So
like,
if we have,
count the molecules and then see how many are on the structure. You don't have to know like the actual structure of it.
yep, so if we have,
Some of them, like, it wanted the names.
For part 2.
Oh yeah, the names. It's just like the same big part.
Oh, you're already doing part
Wait,
2?
let me see.
Yeah.
I haven't done it yet.
I have
Good review right here.
Right, so we can have a,
Don't know how to do.
like that.
It's like this. So it's just like, so it wants you to go in CHO, so it's just,
Oh, I don't know what.
so it's just C, and then there's 1, 2, 3, so 3. H,
Oh.
1, 2, 3, 4, 5, 6, 7, 8. 1.
Oh, so when it comes to naming.
Right.
Yeah. Yeah, so I can show an example up here.
Okay.
So if it's this question up here for your homework,
I was
They
confused
just
at
want
first,
you
because
to-
I was like, oh.
they want you to write the like molecular formula of this. So they just want you to write carbon, how many there are. So there's 1, 2, 3 in this one. Hydrogen, there's 1, 2, 3, 4, and then 1 oxygen. You just put it in like that. But depending on your structure, it should also always go carbon, then a number, hydrogen, then a number, oxygen, then the number. If you have a nitrogen or sulfur, that should be the last one. So that's how you do your homework problem.
And do you have, just while I'm looking at the little graph that you made, graphic,
Mhm.
you have 4 bonds because carbon can hold 4, correct?
Yep, and that's why it's +4.
See,
I've never said any words. Because I didn't know what part was.
Any other questions? How are you feeling about like percent abundance and everything? Is that a?
The what?
Percent
Oh,
abundance?
you go over the 1/6 thing.
I don't think we really covered.
Yeah,
this.
let's go ahead, let's cover that.
I do have a practice problem for you, or a couple practice problems.
Yep.
Love that, so.
That was chapter.
I think that was like the very last thing we did today, yeah, because I don't remember hearing a lot about that today, and I was paying attention.
I think that was the last thing we did on Monday here in Altimos class, or.
Yeah,
In Altimos?
Yes.
yeah, but we didn't like hit it real.
Yeah, we didn't,
Yeah, like I didn't.
it was one that you had to finish on your own.
Oh, it's,
Is it Logitech?
yeah,
It looks like
Logitech. it also doesn't.
That's cool, bro.
Yeah, I love this.
It looks pretty cool. I like it. It's like
It's definitely like pricier, but it's
why
like,
are you looking at me?
She said 1 second.
I got it on
Once
Amazon.
I already got an answer. It's already on her shopping cart.
Just let me down there, it's fine.
Exactly. I kind of like yours.
I feel like I would upgrade my technology about this and have it on just something, still kick it.
Yeah. Like sometimes I go carry it around like this,
Cause that's lighter than having it like all together like that.
and I have like the
Oh, the,
paper.
is it people?
Oh, I do too.
Yeah, but like, you see how scratchy it is though? I have to get a new
But
one.
it's cause you have the pen and it's
Yeah.
weird to.
Oh, but I like that pen. Is it for an actual pen?
It does feel like an actual pen.
And you can see the point, it's not like this big
Mhm.
bulbous round point.
Oh yeah, that does feel more like.
Yeah.
There's like sour.
Is it the TV?
Yeah.
Wait,
I was gonna get that one.
Got it for Christmas. I was so sick of having the black.
Oh, she's wanna.
That's every color I get it. Like it's- and it
I
matches-
think the look is something.
No, yeah, it looks, I think really, I got blue, but I
She's
should
10 years
have
old.
got.
I might be 10 years old. Okay, so for our percent abundance question here, we have lithium has 2 naturally occurring isotopes, lithium-6 and lithium-7. If the average atomic mass of lithium is 6.941, what is the percent abundance of each isotope? Okay, so
Oh, this is like the X and the X
Mhm.
minus
Yep.
1.
So, just looking at our problem here, we know that the average atomic mass of lithium is 6.941. So what isotope, 6 or 7, do we think is gonna be more abundant?
7,
Perfect, why do you say that?
because it's closer to 7.
Yep, right, looking at your average atomic mass, it's a weighted average. We're saying, okay, so much of 6 is gonna be present and so much of 7 is gonna be present. So 7 is in higher demand, where it's pulling us closer to that 7 range over that 6 range. Okay, so when we're going to find our answer for this, we should get a value for the percent of 7 that is much higher than the percent of 6. Do we know what either percent is?
Can't you know from the 6.9?
We can use that. We don't know directly,
Right.
right? We just know that 7 is more abundant than 6. So if we're looking at lithium 6, we want to call this X.
Sure.
We'll say that the percent of this is X. So if we only have 2 isotopes available to us, if lithium 6 makes up X percent, what does lithium 7 make up? 1 minus X.
And she said there was a one that you have to know to put the 1 minus X with, and is that the one that it gives you the mass of, or the one that you're looking for?
So it depends on the question. If I just asked you for the percent abundance of isotope 7 of lithium 7, you would want that one to be X, because then that directly gives you the
What
percent
X?
of X7, or of lithium 7. But in this case, I'm asking you for both, so it doesn't matter.
How do you know it's from -7?
So we have 100, right? We have 100% of this is the lithium. This is going to be lithium 6. This is going to be lithium 7. So 100% makes this up. So a certain percent is going to be 6, a certain percent is going to be 7. So that's 100%, right? So in order to get that into working numbers, you divide by 100, so you get 1. Right, so all of this makes up 1.
And you can just be like, oh, 6.94 is supposed to be 7?
No, because we're looking for the actual percent abundance of both.
Oh,
But we know, right, we drew our figure where 7 is more abundant than 6, because we know it's closer to 6.7 is closer to 6.9. Okay. So we can say that we have 6 times X, right? The mass of that isotope times its percent abundance, plus the mass of your other isotope times its percent abundance, will be equal to your average atomic mass, or that 6.941. And now this just becomes an algebra problem, where you have 6x plus 7 minus 7x is equal to 6.941.
Combine that term.
Combine like terms, so you get minus x plus 7 is equal to 6.941. I like my x positive, so I'm going to add x to both sides while I subtract 6.941 from both sides. And directly we get that x is equal to 0.059. So this gives us our percent.
5.9%.
Good, so we need to multiply it by 100 to get to a percentage. So we get 5.9%. And what isotope does that relate to?
6.
Lithium 6, right? So lithium 6 is 5.9%, where lithium 7 is what?
100 minus that.
100 minus 5.9 would be 94.1.
Can you explain one more time, like if we were quizzed over this, like which one we would know to put the 1 minus X with?
So if I change this from saying, what is the percent abundance of each isotope, to saying what is the percent abundance of,
but can't you find it either way?
yes,
I think she just said it just requires
I
one
think-
order.
yep.
Oh.
So if we said, I guess, let me get this one. Yeah. that's right. So if we said, what is the percent abundance of lithium 7? If we gave this notation of lithium 6 as X and lithium 7 as minus X, when we solved for X, we found lithium 6. We didn't find lithium 7, so we had to take an extra step to find 94.1.
Oh, well,
But if we changed it to say,
you have to know which one.
this was X and this was 1 minus X, now we would solve for X and get our answer directly.
So X correlates to the universal.
Yep.
Got it.
Yep. Yes, it's so that would be how you would know. She only says X, she only says that so that you're not doing extra subtracting stuff, and
Right.
plugging into your calculator wrong. But it's all just preference. As long as you have clear notation of what both of them are, then you're good to go.
This has been very informative.
Yes, thank you.
Yes, is everyone say 5 to 6?
5 to 6, and depending on the chapter, how many people are here, if it's right before an exam, I'm happy to stay a little bit longer, an hour and a half or so. I don't have too many things going on these days. So I'm happy to help you with anything you have. But I think today this feels like a good place to stop. Yes. Okay.
Thank you.
So wrap it up. Yep.
Are you always gonna be amazing?
No, so I will probably be in Heldenfels for the following weeks. It's a little bit bigger of a classroom. And you know, but I will send out an announcement. Yeah. To let you know. I just haven't gotten a password back.
Thank you.
Yeah, absolutely. Thank you so much. Thanks for coming. It was a great Wednesday.
Time.
I do. We need to put something. Where do you have to? Should